What we're going to be doing today is we're going to be talking about Earth's rocks. And I'm talking about actually looking at the rocks to be able to go ahead and make sense of what's happened in Earth's past. So let's get started. So you most likely have seen a picture like this before, where it's going ahead and it breaks down Earth's story into these periods. So you may have heard of Cretaceous period before or Jurassic period, but the question is, how do they figure that out? How do they know what happened? And so it all comes down to looking at the rocks. If we go ahead and take a look at this picture, this is the same thing, but what you can notice is that they're starting to look at the rocks for the information. We look at information about the fossils that are in the rocks that tells us what kind of organisms were around, and when we no longer see fossils, as we go down through the layers of the rock, that starts to give us an idea of when organisms first started to appear. The other thing that we typically look at with the rocks is we start to go ahead and figure out how old the rocks are. So what we're going to be doing today is talking about a little bit more about how scientists are able to figure out how old a rock is, as well as some other information that helps us determine order of things that have happened in Earth's history. So here we go. One of the things we need to make sure we clear on is this principle of superposition, which we've talked in class many times before, so this should be a quick review. Layers that are at the bottom are older. Layers that are at the top are younger. We also have to make sure we start to understand this original horizontality, which was really making sure we understand that layers form horizontally most of the time. So one class period had a lot of deposition of sediment, like say sand. Another group had deposition of sediment in this basin that was very much clay or silt-based. The one principle we are going to be talking a lot about is Uniformitarianism, which is really going ahead and thinking about what we know about current day helps us understand about the past. So here we have the ocean. If you've ever been in the ocean before and you've looked at the bottom, you see these ripple marks. You can see where the ocean current has pushed the sand and has like this kind of a ripple effect. It helps us understand not only what kind of rock it is, but what kind of environment it formed in. The other thing we also kind of make sure we understand is that sometimes layers aren't formed in horizontal positions. One of the ways that this happens is when we think about sand dunes. You think about wind pushes the sand across right here. So you can see, we can start to pay attention to and realize which direction the sand is blowing. And when we start to know the direction of the sand that's blowing, that kind of helps us start to understand what's happened in that environment. So in this case, we can go ahead and show that here is the rock, that this was a sand dune at one time, and that the wind was blowing in this direction. And so we can start to see how these different rock layers are forming, and it tells us a little bit more about the environment, that this was definitely in a... The other thing we need to make sure we start to understand is how scientists are able to figure out about how old a rock is. And that all comes down to what's called radioactive dating. Radioactive dating, we're not talking about boys and girls dating. We're talking about using radioactive particles that are in the ground that are unstable and release radiation. These particles, there's oftentimes a pattern in how they break down into stable particles. Scientists have now learned that certain particles break down at a certain rate. So uranium breaks down at a certain rate into turning into lead, which is a more stable atom or particle. We have potassium, which is unstable and eventually breaks down into argon. And what scientists then do is they take these rocks into a lab setting and they start to go ahead and calculate the percent of atoms that are unstable to the percent of atoms that are stable. And that helps them start to figure out how old a rock is. And so I want to make sure we start to understand here in this picture, you can see that they were able to go ahead and do radioactive dating or radiometric dating to these layers of volcanic ash. The other thing they go ahead and use is what's called an index fossil. And index fossils are organisms that have lived for a very short period of time, but have lived in a lot of different locations around the world. And so if we find this particular fossil in this rock layer, we know roughly when it was deposited, because it's the same all around the world. And so we go ahead and use index fossils along with radiometric dating to help us start to paint this picture of what's happened in our past, as well as how old the rocks are. So here you can see that there is a trilobite, and the trilobite layer So here's our trilobite. This is what's called an index fossil. And we often then can go ahead and determine that it's roughly a certain age, because when we see that layer of trilobites, we have at least a rough estimation of how old that rock is that it's found in.
All right, the one thing I do want to make sure we start to also understand is that when we look at the geological history timeline, it's oftentimes broken down. And so there's what's called eras. And I want to make sure we understand the basic eras that we're going to be focusing on, which is talking about the Paleozoic era, the Mesozoic era, and the Cenozoic era. And so in the Paleozoic era, we're talking about ancient animal life. In the Mesozoic era, most of you guys have probably heard of the Mesozoic era, talking about Triassic. It's broken down into periods: Triassic, Jurassic, and Cretaceous period. But those are all basically known as the age of dinosaurs, or what's oftentimes called the middle life. Now, this event was not just only about dinosaurs. This is also a time when we had much of the terrestrial plants start to go ahead and show up and appear in our fossil record. And finally, we have what's called the Cenozoic era, and that is the era that's oftentimes known as the age of mammals. I do want to make sure we understand that this is when most of the large land animals started to appear in our fossil record, but it's not the only time that mammals appeared. But this is typically when we see the largest land mammals start to appear, is during this period of time.
So I want to make sure we start to understand this basic process. Yes, it's lots of pieces of evidence that put together, and it's kind of like a detective going ahead and trying to use these pieces of evidence to make the story. And I want to make sure we understand that this story changes. The more evidence we gather, the more of a better understanding we have as to what's happened. And so the story may change over time as we gather more and more information. The scientists come up with this story all deals with what's in the rock, how old a rock is, and by going ahead and understanding some basic principles. Rocks that are at the bottom are older than rocks at the top. So we're going to go ahead and stop here. If you happen to have any questions, we will go ahead and continue to work on this in class and dig a little deeper. But at least we should have a basic foundation of the geologic time and understanding that it's using rocks to help us solve this story. We'll see you in class. Bye.